three tables, patients, doctors and visits are given with their relation schema, and we have to identify the relational algebra query which displays the phone numbers and names of all the surgeons. So first of all, we need to identify the table from which we can get the required information. Here we want names and phone numbers of surgeons. So if you observe doctor's table, the attributes are dnum, dname and rank. Means doctor number, doctor name and his rank. So and we don't want names and numbers of all the doctors. We just want only numbers and names of surgeons. So for that we have to write a query as select rank is equal to surgeon from doctor's table. So this query select all the doctors who are surgeons. So and from this table we need only number and name. So we have to project those two columns, dname and dnumber. So this inner part identifies the doctors who are surgeons, and from that table this projection operation selects only name and number columns. So this is our required answer, which is option A.
Which of the following statement is /r true? So two statements were given. We need to find out the true statements. If a language L and its complement L dash both recursively enumerable, then both languages are recursive. Statement S2 is, if a language L and its complement L dash are both recursive, then both languages are recursive enumerable. So actually here the recursive is subset of recursive enumerable. So the recursive languages are closed under complementation, but if a language which is recursive enumerable but not recursive, whose complement is not closed, whose complement is not a recursive enumerable language. So that's why, so if a language L and its complement L dash both are recursive enumerable, then L must be recursive. If L is recursive, then only both L and L dash will become recursive enumerable. If L is not recursive, it will not happen like that, because every recursive is recursive enumerable, but not all recursive enumerable are recursive, because recursive is subset of recursive enumerable. Statement S2, if a language L and its complement L dash are both recursive, then both languages are recursive enumerable, because every recursive language is a recursive enumerable language. S1, S2 both are correct. So option C is the correct option here. Both are true. L be a DCFL. DCFL means deterministic context free language, and R be a regular set, then which of the following is decidable? Is /R decidable? Because one or more may be decidable. The one is L regular? 2 is L is equal to R? The question 3 is R is subset of L? So these are the three things given. Is L regular? That is the question. So we can find out anything, yes or no answer we can say if there is a procedure. If you want to say when L is regular or not, if there exists a DFA, so we can check that language with DFA. If language is accepted by DFA, it is regular, otherwise it is not regular. So for comparison of DCFL and regular language, there is no algorithm exist. So is L is equal to R, we can't say. Is R subset of L? If you want to find out whether R is subset of L or not, first of all we must be able to find out the intersection of R and L. There is no procedure to find the intersection for the DCFL and the regular language. So that is why, so 2 and 3 are not decidable, but only 1 is decidable. So option A is the correct option here. Option A is the correct option, because is L regular is only decidable.
Here a relation and its FD set are given, and we need to find 2NF tables for that relation. For a table to be in 2NF, there should not be any partial dependencies. So first we have to know what are partial dependencies. If there is an FD of the form part of the key to non-key, then this is called partial dependency. So we have to eliminate partial dependencies first. Here given FDs are AB gives C, A gives DE, B gives F, F gives GH, D gives I. So first we have to find key for this table. Here key would be AB. Why? Because AB plus gives all the attributes of the table. That is, AB plus gives is equal to A, B, C, D, E, F, G, H, I. So if AB is the key, then partial dependencies would be A gives DE. Why? Because here A is a part of the key and DE are non-key attributes. So this is partial dependency, and B gives F is also partial dependency. Why? Because B is part of the key and F is a non-key. So we have to eliminate these two partial dependencies for the table to be in 2NF. So the functional dependencies which are violating 2NF should be kept in separate tables. So we will keep ADE in one table, and BF in other table. So for this table, functional dependencies would be ADE, A gives DE, and key is A. For this table, B gives F is the FD and B is the key. And we'll keep the remaining attributes in the third table. What are the remaining attributes? C, G, H, I. So these are the remaining attributes, and in order to maintain the relationship between these three tables, we'll keep A and B as foreign keys in this table. So these are the 2NF tables for this question. So which is option D.